Okay, Loudepot back here with a simple math calculation. Anytime you got to figure out how much heat to put in a room, you first have to do a heat loss calculation for that room. Whether it's baseboard, radiators, radiant heat, anything, even air conditioning. The BTUs out must be replaced by the BTUs in, and that's simply how it works. And by the way, when you talk BTUs, they're talking per hour. Okay, heat loss in BTUs per hour. Every time you do a heat loss calculation, or you want to calculate what you're going to do, you need to have an indoor temperature of a set temperature of what you want to be comfortable at. For this exercise, we're going to use 70 degrees Fahrenheit or 20 degrees Celsius, which is the same thing. And you have to have an outdoor temperature or an outside temperature. It's worst case scenario, because on the coldest day of the year, on a January night, you don't want to be freezing. So for that outside temperature, we're going to use 0 degrees Fahrenheit or minus 18 degrees Celsius, which is the same thing. And what I'm going to do is simply put you to put the camera on one of the charts that I used in school. This is for calculating a radiant heat baseboard, radiant heat flooring, not baseboard, radiant heat tubing under the floor at outside temperature 0, inside temperature 70. Now you'll quickly see that the thicker the insulation is in the wall, the lower the number that they want you to use to times by the square foot, which is going to give you the BTU loss. The thicker the insulation, the lower the number. The thinner the wall, the thinner the insulation, the higher the number is going to be, because that's going to be a greater BTU loss. I just want you to understand that. And I'll put the camera on the book so you can understand that. Now we'll start up here with ceiling. As you can see, R11 insulation, which is pretty thick, and they also have it for R19. And now because we're going at 0 degrees, they want you to use the number 7 for R11 and the number 4 for R19, only 2.5 for R30, which is thicker, and 2 for R38. If the ceiling is heated, the space above is heated, you would use 0 because you're not even going to calculate the heat loss. There wouldn't be any if the place is heated above. And then simply you would put that number right here times the square foot, and that would give you the BTU loss. It's that simple. So if you had 100 square foot and it was R11 insulation, I'm sorry, you would put a 7 there, and it would be 7 times 100, so your heat loss would be 700 BTUs per hour. And it's that simple. And this whole chart gives you everything for the ceiling, then everything for the walls, then you would do the floor, and then windows and skylights, and all the numbers are there. And the math would be done on the right. So you would have numbers for your ceiling, then for your walls, then for your floor, and then windows and skylights. And this way at the end you would add all these numbers together. All these BTU numbers is what you're looking to come to. And then you would come up with the number of 3,000, let's say. I'll put you back. So real quickly, if you came up with the number of 3,000, which is normal, and you had a 100 square foot room, you would need 30 BTUs per square foot to make up for that 3,000. Most rooms, when you do radiant heat, vary between 20 and 30 BTUs per square foot. How do you adjust the BTUs? By the temperature of the water and by compressing the loops like we went through before. Okay, so by compressing the loops and running the loops tighter and running the proper temperature of the water, you can get 30 BTUs out of a floor. Now remember, there's different R values for floor too. Hard tile might be like 0.5 or 0.5, where thin carpeting may be like a 2. So you have to calculate for that too, and we'll go over that too. But that's just a good idea of how to get to the number of BTUs so you can have an idea how to calculate. And by the way, you guys in Alaska, I didn't want to put too many numbers on the board, but I know that we did it at 0. Let's see here. We did the factor at 0 BTUs. There is actually numbers for everybody. There's numbers for you guys in Alaska. So if you were going to be at -20 and you wanted to, or -10, or maybe you're in a warm area, 10 or 20 degrees at the lowest possible point, those numbers are all there for you. And I'll kind of go down the list for you. We used 0 in the exercise. Okay? And then that number that you come up to would go here, and it would just simply be that times the square foot, and that would give you your BTU number. Once you add up all your BTUs together, that's your heat loss for that room per hour, and that's what you have to make up per hour. And there's a lot more charts. That's just one simple one. It's a quick one. It works 99% of the time. There are other factors that you may have to consider, but that'll give you a real good, close idea of what you need per foot and how to start preparing to do your radiant heat. Okay, so this should help you.